Hello and welcome to another lesson on GCSE physics. To go through this video lesson and get the best out of it, it would be great if you could have a pen and paper available to you as well as a calculator. Today's learning intention is to know how our understanding of atoms has changed over time. The success criteria for today is to describe the difference between the plum pudding model of the atom and the nuclear model, and to evaluate the way in which Rutherford's scattering experiment has impacted on our understanding of the atom. So, the first model of the atom that we had was introduced by John Dalton in 1800. John Dalton proposed that atoms were tiny spheres that couldn't be divided. He took his idea from Democritus, who in 460 BC first proposed the idea that there were things that were making up other elements, and he did research and calculated things such as atomic weights, etc. At this time in 1800s, protons, neutrons and electrons had not yet been discovered. If we fast forward 97 years, we come to Thompson's model of the atom, which was called the plum pudding model. He came up with this idea after electrons had been discovered. He proposed that atoms were made of a ball of positive charge with electrons scattered throughout the positive charge, in essence a little bit like a plum pudding. You can see the diagram there that shows the orange as being the spherical cloud of positive charge, and then we've got the electrons scattered throughout them. In 1906, Thompson was actually awarded the Nobel Prize for his work in this field. Now in 1909, Rutherford did experiments, which we're going to look at in more detail later in this video, and these allowed him to develop his own version of the atom, which was called the nuclear model. He came up with the idea that there was a positive nucleus at the centre of the atom with electrons orbiting around the nucleus. He also concluded that most of the atom was empty space. Again, you can see a diagram there on the right hand side of the board showing the nucleus in the centre, the positive nucleus in the centre, with the negative electrons orbiting it. Niels Bohr then refined this model in 1913 by slightly updating it. Bohr's model was almost identical to Rutherford's in that there was still a nucleus that was made up of protons and neutrons, but the electrons orbiting the nucleus would only orbit it at specific distances away. Bohr called the specific distances that the electrons would orbit the nucleus as energy levels. There's a diagram there showing this on the right hand side that shows there that the electrons remain each a specific distance from the nucleus. Now, work on quantum physics has then shown that electrons can actually move from one energy level to another. They can do this by either emitting or absorbing electromagnetic radiation, which is what the GIF there on the left hand side of the board is showing. If the electron absorbs radiation, it will move to a level that is further from the nucleus, and we refer to that as being a higher energy level. If the electron emits the radiation, which means gives out the radiation, it will move to a level closer to the nucleus, or a lower energy level. We're now going to watch a video that is going to explain how Rutherford came up with his model of the atom, his nuclear model of the atom. This video shows how Rutherford worked with two PhD students, Geiger and Marsden, and this links very well to our curriculum for life because it shows respect, which is one of our character virtues, and it also shows ambition, a second one of our character virtues. The video that we just watched showcased the experiment that Rutherford and his students Geiger and Marsden did to learn more about the structure of the atom. This experiment was called the gold leaf experiment, and now we're going to look at it in a little bit more detail. This diagram shows the setup of the gold leaf experiment, otherwise known as the alpha particle scattering experiment. Now you can see that there's quite a bit going on. The whole experiment was actually conducted in a vacuum chamber. A vacuum is a place where there are no particles whatsoever. Now it's important that this experiment was done in a vacuum chamber so that the alpha particles wouldn't be absorbed by any air molecules. You can then see as well here that we've got a detector placed on one side of the gold foil, and then we've got the source of the alpha particles on the opposite side. Now what Geiger, Marsden and Rutherford actually did, I'm just getting a laser pointer to make this clear, is they fired alpha particles from this source here through a very thin piece of gold foil and then detected it on the other side. Now, what they obviously found was that the vast majority of the alpha particles went straight through the gold foil and were detected by the detector there. But as the videos just explained to us, a very small number of alpha particles, when they got to the gold foil, were actually deflected back by a very large angle and detected on the same side of the gold foil as the source of the alpha particles was. Now, we can see that if we look at this a bit closer up, we've got alpha particles here travelling towards several atoms. Now, most of the alpha particles will pass straight through, which they are doing, but a small number of alpha particles actually deflect backwards by a very large scattering angle. Now, what I would like you to have a go at for me, please, is to write your own explanation to answer this question. Why was the plum pudding model of the atom replaced by the nuclear model of the atom? Now, I would like to pause the video and answer this question in as much detail as you can using what you have learned in today's lesson. You will receive a score of 8 marks for your work, or up to 8 marks, so I'm expecting an extended piece of writing for this. Pause the video and have a go. So, now that you've had a go at answering this question, let's look at the different things that you can be awarded marks for. Any of the points that you have missed out, I would like you to add to your working green pen, please, because these are all points that you could receive marks for in the actual exam. So, let's begin with them. The plum pudding model was replaced because of the alpha particle scattering experiment. So if you just mentioned that the results of this scattering experiment was why the plum pudding model got changed, that gets you 1 mark. You can expand on that and say the results from the alpha particle scattering experiment couldn't be explained using the plum pudding model of the atom. Therefore, scientists had to come up with a new model of the atom. This is the type of thing in science development that happens all the time. We have one model for explaining how something works, but when we get more results or more evidence that can't be explained by that model, we have to come up with a new model to explain it. This has happened in countless different things. Obviously, we're looking at the structure of the atom today, but you could also consider the model of the solar system has evolved in a very similar way to this. Now, what else can we get marks for then? We can get marks for describing how the experiment was carried out. We can say that alpha particles were fired at gold foil. There's another mark for saying the gold foil had to be thin so that the alpha particles could pass through it. And another mark for saying the experiment was done in a vacuum to prevent air molecules from absorbing the alpha particles. So far you can have 6 marks, but obviously this task was out of 8. So you can have 2 more marks for saying that most alpha particles went straight through the gold foil, which suggested that most of the atom must be made up of empty space. And then if you haven't got 8 marks yet, other marks can be given for saying that some of the alpha particles were deflected backwards or scattered by very large angles, and that meant that most of the mass of the atom must be concentrated at the centre, and the nucleus of that concentrated mass is positive because it repels the alpha particles. So there are a total there of 11 different marking points, which you can score a maximum of 8 for this task. I'd like to have a go now at doing this gap fill. It's across 2 slides on the board. Pause the video, complete the gap fill, and then mark your work. So atoms are mostly, of course, empty space with a nucleus in the middle. I'd like to be using the phrase empty space as well. Don't try and paraphrase that. Empty space is the exact way we should be phrasing this. The nucleus, of course, contains protons and neutrons. It doesn't matter which order you put those 2 words in. Surrounding the nucleus are electrons, which have a relative charge of -1. The protons have a charge of +1, and the neutrons have a relative charge of 0. Well done if you've got all of those correct. Now we'll have a look at the second half of the gap fill. In an atom, the number of protons is always equal to the number of electrons. Now we know that the electrons can change their distance from the nucleus if they absorb or emit electromagnetic radiation. they move towards the nucleus if they emit the electromagnetic radiation, and away from the nucleus if they absorb the electromagnetic radiation.